Okay, so for objective 1, it says distinguish between sigma and pi bonds. And since it says distinguish between them, that implies what are differences between them. I want to make sure you realize the thing that's similar is they're both covalent bonds. Okay, people kind of forget that we're talking about covalent bonds here. But remember, this whole chapter was about covalent bonds. So they're both covalent bonds, but the difference is, when does a sigma bond form? It's always the first one. It's always the first pair. It's always the first bond between two atoms. Not in the whole molecule, but between two atoms. So then when does a pi bond form? Yeah, it's the second or third pair. We'll put and or. Okay, so the sigma bond gets the center position. That makes it, of the two of them, the sigma bond's going to be stronger than the pi bond. So the pi bond will break off more easily, leaving you just a single bond. But overall, a double bond is definitely stronger than just a single bond. A strong bond and a weak bond is still stronger than just one bond by itself. So an example, NO2 minus 1. In order to do this example, you have to be able to draw NO2 minus 1. So this will be good review of how you draw covalent structures. So best thing you can do is forget that you know how many valence electrons nitrogen have once you get your total here. Nitrogen has 5 electrons it can share. Each oxygen has 6. The minus 1 tells me it gained an electron somewhere. So I add that in. So my total here is 18 electrons. Now I forget who had what. It doesn't matter that oxygen brought 6, that nitrogen brought 5. I put nitrogen in the center because it's the first one listed. I attach each oxygen with a single bond, and then I see what it would take to get them stable. So oxygen would still need 6 more electrons, or 3 lone pair we call those. This oxygen would need 6 more or 3 lone pair. And this nitrogen still needs 2 pair or 4 electrons. So the question is, did that take 18 electrons or did it take more than 18? And if I count, it's 2, 4, 6, 8, 10, 12, 14, 16, 18. It actually took 20 electrons. So that means I minus 2 on my electrons, which means I used 2 more than I have. And that's not possible. You can't just invent 2 electrons. So what that tells me is when I see a minus sign, it tells me to share more. And you share more by making a double bond. If it was minus 4, I'd make 2 double bonds. Or if I only had 2 atoms, I'd make a triple bond. But I have to share more. So I'm going to redraw this. I'm going to make one of these a double bond. I'm going to leave the other one a single bond because I was only short 2 electrons. And now I'm going to look at what oxygen needs. This oxygen needs 4. Now nitrogen only needs 2. This oxygen still needs 6. But now when I count up, I have 2, 4, 6, 8, 10, 12, 14, 16, 18. I've used 18 electrons. And all 3 atoms have the octet rule satisfied. All 3 atoms have 8 electrons. I should put brackets with the minus 1 to show that I know I picked up an electron somewhere. I'm not going to worry too much about that on the test. If you get the structure drawn correct, I'll be pretty excited about that. Yeah. No, I didn't mark anybody off on the homework quiz for that. So then back to pi and sigma bonds. Where are the sigma bonds here? How many sigma bonds are in this molecule? 2, because one of these is, and the first bond there So I've got 2 sigma bonds, and then the pi bond is the other one. Oops. Oh no, it's going to mess it all up.
Call 88052, please. Arthur Crutch, call 88052.
So this one and one of these. Can't spell here. And it's going to be the other one right there. Okay, so that's sigma and pi bonds.